There's a gallon of white distilled vinegar sitting on a shelf at your grocery store right now for under $2, and it will do something to your water heater that no licensed plumber will ever mention when he hands you a bill for $1,500. The U.S. Department of Energy has documented that sediment buildup inside a standard residential tank increases your energy consumption by 15% or more every year, quietly, on your bill. That same tank, left unmaintained, is statistically likely to fail within 8 to 12 years, not because it wore out, but because it was never cleaned. A $2 intervention performed once a year has the documented potential to extend that lifespan to 20 years or beyond. Not almost as good, not comparable, measurably, provably better. It removes the sediment layer, it stops the thermal stress cycle, it gives the sacrificial anodrot a fighting chance. The U.S. Geological Survey confirmed that 85% of American homes have hard water. The Department of Energy confirmed the energy penalty in published efficiency data. The water heater replacement industry, manufacturing and professional installation combined, is a $32 billion market. They did not forget. This existed. That would be an accident. They buried it. That was not an accident. It was a decision. This is the story of the annual flush and acid wash and what it does, and why the knowledge to double your appliance's life was never supposed to reach you. Welcome back to Science of Survival, where we open the vaults. Hit subscribe and the bell if you are not already in. In the winter of 45 BC, on the western bank of the Tiber River, Roman engineers faced a problem that would be immediately recognizable to any homeowner in the American Midwest today. The aqueduct system feeding the baths of Agrippa and the broader city infrastructure of Rome carried water drawn from sources high in the Apennine Hills, water rich in dissolved calcium and magnesium carbonate, the same mineral profile that the USGS now classifies as hard water. The Romans did not call it hard water. They called the white crystalline scale that accumulated on the inner walls of their lead and clay distribution pipes calx, from the Latin for lime, and they knew from careful observation over generations of engineering that calx reduced flow, trapped heat unevenly, and eventually cracked the vessels it colonized. What they discovered empirically, without spectroscopy, without a chemistry degree, was that acidic solutions dissolved the scale completely. Roman records, including references preserved in the writings of Pliny the Elder in his 1st century work Naturalis Historia, document the use of diluted vinegar to flush and clean cisterns, pottery vessels used for heating water, and the stone channels of hypocaust heating systems. The results were observable. The scale softened. It loosened from the surface. The water ran clearer. The vessels lasted longer. They smelled the acetic acid working. They saw the fizzing reaction where calcium carbonate met the acid. They measured the outcome in years of continued use. For centuries passed before anyone outside the Mediterranean basin encountered this same principle again in a documented, systematic way. 4 centuries later, on the other side of the known world, in the Tang Dynasty workshops of 7th century China, artisans responsible for maintaining the bronze and ceramic vessels used in tea ceremonies and medicinal preparation faced an identical problem. Hard mineral deposits, the same calcium carbonate built up inside the vessels used to heat water repeatedly over charcoal fires. The solution they arrived at independently was rice vinegar. Acetic acid, by a different name, from a different fermentation process, discovered by observation of the same chemical reaction. The deposit dissolved, the vessel was preserved. The technique was passed between craftsmen and recorded in household management texts of the period as standard practice for extending the life of valued equipment. Centuries later, in the colonial American period of the early 1700s, households using iron kettles and copper boiling pots over open hearths for daily water heating documented the same white crust formation in domestic record books and household management guides of the era. The solution passed through families orally and, in written household guides, boil vinegar in the kettle. The fizzing was the indicator. When it stopped, the scale was gone. 3 civilizations, 3 continents, 0 contact, identical observation, identical solution. That is not coincidence. That is acetic acid reacting with calcium carbonate, the same chemistry, rediscovered independently wherever people heated hard water in enclosed vessels. In 1994, researchers working with published efficiency data from the U.S. Department of Energy formalized what Roman engineers had observed empirically 2,000 years earlier, that mineral sediment accumulation at the base of a water heating vessel fundamentally compromises thermal transfer. The mechanism is specific. When water is heated above 120 degrees Fahrenheit, dissolved calcium and magnesium ions, the defining mineral signature of hard water, present in 85% of American homes according to USGS survey data, undergo a phase change. They precipitate out of solution. They crystallize. The technical term is thermal precipitation, and it is not a slow process. It is continuous. Every heating cycle deposits another thin layer of calcium carbonate at the lowest point of the tank, directly above the burner in a gas unit, directly above the lower heating element in an electric one. Over months and years, that layer becomes a stone barrier, dense, low conductivity, thermally resistant. The burner must now work harder and longer to push heat through that barrier into the water column above. The DOE's published data puts the energy consumption penalty at 15% or more per year of unmaintained operation. Read that number again, 15%. On a gas water heater running at roughly $30 a month in energy costs, that is $60 to $120 per year, silently extracted from your household budget by a layer of mineral scale that costs $2 to dissolve, but the energy penalty is the minor consequence. The structural consequence is what ends the appliance's life. As the burner overheats the bottom of the tank to compensate for the sediment layer, the internal glass lining, the only barrier between your water and the raw steel tank wall, experiences repeated thermal stress cycles. It develops microfractures. Once the lining is compromised, the tank's only remaining defense is the anode rod, a magnesium or aluminum sacrificial element designed to corrode, preferentially protecting the steel. The anode rod was never designed to compensate for a compromised lining accelerated by sediment-induced overheating. It depletes faster, and when it is gone, the raw steel wall corrodes, the tank fails. This is not a design flaw, this is a designed outcome. The interesting thing about buried knowledge is that it only stays buried if nobody talks about it. The moment people start sharing it, the burial ends. So why is this not on the first page of every water heater owner's manual sold in America? Here is what a $32 billion industry looks like. The residential water heater manufacturing market is dominated by three corporations that together control the overwhelming majority of American tank installations: A.O. Smith Corporation, Rheem Manufacturing Company, Bradford White Corporation. These three companies produce units with a documented design lifespan of 8 to 12 years, a lifespan that assumes the unit will never be flushed, never be descaled, and never have its anode rod inspected. The business logic writes itself. You cannot patent the annual flush. You cannot trademark the calcium carbonate dissolution. Reaction. You cannot build a subscription revenue model around a garden hose and 2 gallons of white vinegar. You cannot charge recurring service fees for knowledge that any homeowner can execute in an afternoon. The replacement cycle, however, that is a different architecture entirely. A new tank installation generates $1,500 to $3,000 per household. In a country with approximately 80 million single-family homes and a replacement cycle of 8 to 12 years, the arithmetic is not complicated. The plumbing services industry adds another layer. A professional tank flush, which consists of connecting a garden hose and opening a valve, is billed at $100 to $300 by licensed plumbers when it is offered at all. Many plumbing companies do not offer routine flush services. The financial incentive to not offer them is identical to the financial incentive to not print maintenance instructions on the first page of the owner's manual. Maintenance instructions do exist in those manuals. They are buried in appendices, written in passive technical language. Accompanied by no photographs, no diagrams, no step-by-step clarity, the information is technically present. It is just presented in the format least likely to produce a competent DIY outcome. That is not oversight. That is architecture, deliberate and sustained. Now here is exactly what to do with the annual flush and acid wash. Gather your materials first. You need 1 standard garden hose. You likely already own one. You need 2 to 4 gallons of white distilled vinegar, available at any grocery store or big box retailer for approximately $1 to $2 per gallon. Total material cost $2 to $4. You may need a socket trench or impact trench if you intend to perform the advanced anode rod inspection. More on that shortly. Step 1. Kill the power. For a gas unit, turn the gas valve to the pilot or off position. For an electric unit, flip the dedicated 30-amp breaker to the off position. This is not optional. This is the most critical safety step in the entire process. Water inside a working tank can exceed 140 degrees Fahrenheit. That temperature causes severe, immediate scalding burns. Step 2. Shut the cold water inlet valve at the top of the tank. Turn it fully clockwise until it stops. Step 3. Wait 30 to 60 minutes. The water must cool to a safe handling temperature before you open any drain valve. Step 4. Attach your garden hose to the drain valve at the base of the tank. Route the other end to a floor drain, a utility sink, or outside to a safe discharge point away from landscaping, as the sediment-laden water is not ideal for plants. Step 5. Open a hot water faucet somewhere inside the house. This breaks the vacuum inside the tank and allows it to drain freely. Without this step, the tank will drain slowly or not at all. Step 6. Open the drain valve. Allow the tank to empty completely. Once empty, briefly open and close the cold water inlet valve 3 to 5 times in rapid succession. This power flush action dislodges and expels any loose sediment that has settled but not yet drained. Watch for the water running clear from the hose end. That is the indicator. Clear water means the loose sediment load has been expelled. Step 7, the acid wash, which is the step no manual ever walks you through clearly. Remove the anode rod from the top of the tank. This requires a 1 1/16" socket. On tanks that have never been serviced, this rod may be corroded in place and require significant torque. A breaker bar or impact trench may be necessary. Note, if the rod breaks loose with extreme difficulty or if the threads are damaged, consult a plumber before proceeding. Once the anode rod port is open, pour 2 to 4 gallons of white distilled vinegar directly into the tank. Through that port, refill the tank with cold water by briefly opening the cold water inlet. Then close everything and let the solution sit for 24 hours. Watch for a faint vinegar smell from the pressure relief valve or nearby faucets. That is the process working. The acetic acid is in contact with the calcium carbonate scale layer and is actively dissolving it. If you see no visible results after draining, meaning the expelled water runs clear from the start with no white or yellowish sediment, check 3 things. First, confirm the tank was actually full of water during the soak, not partially empty due to a vacuum issue. Second, confirm the vinegar concentration. Standard white distilled vinegar at 5% acidity is the correct product. Third, consider that a relatively new or recently serviced tank may simply have minimal scale accumulation, which is the best possible outcome. For maximum safety, never perform this procedure on a tank that is already showing active leaks, visible rust holes, or dripping from the base. A compromised tank structure is not improved by flushing, it is a replacement scenario. Step 8, drain the vinegar solution completely. Flush with cold water by opening the cold water inlet and allowing water to flow through the tank and out the drain hose until it runs completely clear and odor-free. This typically takes 2 to 3 full tank volumes of flushing water. Close the drain valve. Reinstall the anode rod. Consider replacing it if the existing one has corroded more than 50%. Refill the tank. Allow all air to bleed from the open indoor faucet until a steady water stream flows. Then close the faucet and restore power or relight the pilot. $2 to $4 in materials, performed annually against a $60 to $120 annual energy penalty from sediment, and a $1,500 to $3,000 replacement bill arriving 8 to 12 years ahead of schedule. The Romans dissolved calcium scale with diluted acid in the 1st century. The Department of Energy documented the 15% energy penalty in published federal data, and 3 companies controlling the American water heater market designed their owners' manuals to make sure that connection was never made clearly in a single room in your house. This knowledge did not disappear. Someone made sure it stayed buried. What else do you think got buried the same way? Drop that in the comments. What did they never teach you that you had to find yourself? If this video opened something for you, subscribe now. The next vault opens soon. What is inside is even heavier than this.